Here's an example in which we've got a pilot flying over a straight highway. He determines the angles of depression to two mileposts, 7 miles apart, to be 31 degrees and 50 degrees as shown in the figure. So you see you've got milepost A and milepost B. They're 7 miles apart. See the 7 right there. And the angle of depression, this is called an angle of depression, meaning it goes from the horizontal down and from the horizontal down. So this is the plane up here. So the plane's up here flying, and those are the angles down from the horizontal, is what we're talking about on this problem. So I'll put the plane up here, and he's flying that away, let's say, and he's got those angles of depression where he's looking down to A and B. Well, using this information, they want us to find two things. Find the distance from the plane from point A, meaning how far is that, right? From the plane to point A. What is that? How far is that? So, how are we going to do that? Well, this is not a right triangle, right? There's not a 90-degree angle. So let me write that. So it's not a right triangle. So we cannot use SOHCAHTOA, right? SOHCAHTOA has hypotenuses in it, which is only in a right triangle. So we're going to use the law of sines. But let's do a couple of things first off. So one important thing to know is that this angle has got to be 31 degrees and this angle has got to be 50 degrees. How is it I know that? Well, this is horizontal, right? Even if you might say, well, how do we know the plane? Never said the plane is flying horizontal. No, it didn't say that. Correct. The plane might not be flying horizontally, but it did say this angle here and this angle here are angles of depression. Depression means down from flat horizontal. That's the meaning of the word. So from that word, they're signaling to us, oh, these are measured from flat. So this line is horizontal, and this is the ground, which we're assuming is flat horizontal. So those are parallel, okay? So what? Well, then that means this angle must match that angle. From geometry, it's called alternate interior angles. When I teach geometry, I would always say it's the z angle. See the two angles the z makes? They're going to be equal if that top of the z and the bottom of the z are parallel lines, which they are. They have to be because the ground is flat and we're measuring these angles from horizontal. That's what a depression angle means. So, yeah, and then here's a backward z. Forward or backwards z angles, where the top of the z and the bottom of the z are parallel lines, are equal angles. That's called, again, alternate interior angles is the official geometry name. Those two angles have to be the same. They look the same, don't they? You can kind of feel it, right? However far this comes down from horizontal, this has to go up, right? Because this one line cuts between parallel lines. So this and this have to be the same. And this line cuts between these parallel lines, so this and this have to be the same, and they are. Okay, so that's helpful. So we start with that, and now we can use that to find the angle up here. How so? So I'm going to do that. So first off, I'll say the z angles are equal. It's technically called alternate interior. And so step 2, the top angle must equal 180 minus the other two, right? Because a triangle always holds 180. So we're having to do a slight bit of geometry here. So the top angle must equal, what's that, 81? So it's going to be 99 degrees, I think. So the top angle up here must be 99 degrees. So now the triangle holds 180. We've got all the angles. And so what are we trying to find? We're trying to find this side over here. Let's call it x. That's what we're trying to find. How are we going to do it? Well, again, we can't use SOHCAHTOA because we don't have a right angle, but now we have an angle and the side opposite, right? We have the 7, we have the 99. We have an angle and a side opposite, so that means use law of sines. Whenever you got that, we have 99 degrees and opposite side 7. So whenever you've got a matching pair with angle and opposite side, that's when you want to use law of sines. So use the law of sines. That's what the law of sines is all about. Angles and sides across from it. So that means what? That means 7 over the sine of 99 degrees. Remember how the law of sines works. Any side over the sine of the angle opposite equals any other side over the sine of the angle opposite, those two, which is what we want. X over sine of 50 degrees, right? Those have to be equal, and now we can solve for x. Do you see that trickery? Diagonal, diagonal. We're going to get 7 sine 50 degrees is x. Sine 99, finish solving for x. Divide by the sine of 99 degrees. Boom, boom. X equals, hit the buttons on your calculator. 7 sine 50 divided by sine 99. I'm getting 5.42915. It's plenty of accuracy. I don't know how much rounding they want. 5.42915. So that's this side right here, right? That's the distance the plane is from A. That's what they asked. I called it X. Now, for their second question. Find the elevation. The elevation of the plane. Elevation. How do we do the elevation of the plane? Well, we're going to have to get rid of this stuff here. Get rid of that 99 even. I don't need it. And let's draw what we're trying to find. We're trying to find, here, let me do a different color. We're trying to find that. Isn't that what we want? Isn't that the elevation or height of the plane? Right? It has to be straight down to the ground. You know how to measure height, right? How do you measure your own height? You don't go diagonally down to the ground, right? You'd be ready for the NBA. You'd have a super high height, right? We know height or elevation is straight down to the ground, isn't it? That's what elevation is, straight down to the ground. So that's the height of the plane. Ah, nice. Notice if we do that, we've got a right angle. This is a right angle, isn't it? It's a right triangle. Just the right side. Just here. Let me shade it for clarity here. Just this guy. I don't care about the left side at all. That, just the left side. That's a right triangle. So what? So we can use SOHCAHTOA. It's SOHCAHTOA time. We don't have to do law of sines for this. We can use SOHCAHTOA. We're trying to find the elevation. Call it H for height. You know, we're trying to find that. How are we going to do it? Well, we know X over here already. We found that from the last bit of work we did. This X is 5.42915, right? So we can use this 31-degree angle, and this is opposite hypotenuse, right? You tracking with me? This is the opposite side. This is the adjacent side. This side's the hypotenuse of the right triangle, that little bitty shaded right triangle. So what is opposite over hypotenuse? Sine. So let me come down and write some of what I just did a bunch of math without writing anything. So number 4, now use elevation and right triangle. So we're going to use SOHCAHTOA, specifically this one because we have opposite and hypotenuse, right? So the sine of that angle, what is that angle? 31 degrees is h over x. Sine of 31 degrees, sorry, I'm getting scribbly, 31 degrees is the opposite, which is h over x, which is 5.42915. This right here is opposite, and this is hypotenuse, right? Opposite over, see it right there? Opposite over hypotenuse. All right, so now we can solve that little equation for h. How do we do so? Put this over 1 to make it look like a fraction, diagonal, diagonal. So 1 times h is 5.42915 times the sine of 31 degrees. So 1 times h is just h. So h will be that number times the sine of 31 degrees. I'm getting 2.79622. 2.79622. 2.79622. That's how many miles high that airplane must be flying at the moment it takes those sightings. So there we go. We used law of sines for the first part. You had to use a little geometry, actually. The z angles, the alternate interior angles for the first part, and then found the top angle by subtracting from 180. Then we used law of sines to solve for x, and then we observed we could, for elevation, it comes straight down. That's what elevation means. We formed a right triangle, and we used the SOHCAHTOA because we had a right triangle now. And so this is opposite over hypotenuse, that's sine, and we're able to finish it.